Okay, now for question number 9, part A. First, we want to prove this is 0. So first, we need to find out a square first. So a square is this one multiply itself. So according to the matrix multiplication, row by column. So you get the first number is this 1. Similarly, second number. So after simplify, this is a square. So a cubed is a square times a. So it is equal to 100, 121 minus 1 minus 1 0 times 0 1 1 3 minus 1 minus 2 minus 2 1 2. So after simplify, you get 0 1 1 4 0 minus 1 minus 3 0 1. Now then we will try to add up the left hand side. So a cubed, a to the power 3 is 0 1 1 4 0 minus 1 minus 3 0 1 minus a squared 1 0 0 1 2 1 minus 1 minus 1 0. A is 0 1 1 3 minus 1 minus 2 minus 2 1 2, and the last one is 1 0 0 0 1 0 0 0 1. And then you further simplify, you will get it is a 0 matrix. So we prove part A. Now for part B, there are different ways to do it. The first method is prove it by the mathematical induction. So B1, we let Pn be the statement. An is equal to an minus 2 plus a squared minus n for n greater than equal to 3. So we let the n when n equal to, the first one is 3. So the left hand side is a cubed, and then by the a part, a cubed can be written as a squared plus a minus I. So it is the same as the right hand side. So therefore P3 is true. So we assume that Pk is true for k greater than equal to 3. That is a to the power k is a to the power k minus 2 plus a squared minus I. So for n is k plus 1. The left hand side is a to the power k plus 1. That is a to the power k times a. So by the induction hypothesis, so it is a k minus 2 plus a squared minus I times a. So after simplify, it is k minus 1 plus a cubed minus a. And then by part A cubed minus a is a. It is a minus I. So it is exactly the same as the right hand side. So by the principle of Mi, Pn is true for n greater than equal to 3. Okay, now for question 9b, we want to find a to the power 8. So by a1, by b1, so by b1, a to the power 8 is a to the power 6 plus a squared minus I. And then we repeat the same relation for a6, so it becomes a to the power 4 plus a squared minus I. And then afterward, we apply on a to the power 4 again, so it becomes a to the power 2 plus a squared minus I. And these two grouped together is 2a squared minus I. So further simplify, we have 4a squared minus 3i. So that is 4. Now a squared by part A, it is 1 0 0, 1 2 1 minus 1 minus 1 0 minus 3, 0, 0, 0, 3, 0, 0, 0, 3. And then simplify, we get the answer 1, 0, 0, 4, 5, 4, minus 4, minus 4, minus 3. Now for B1, we may have other possible method to do it. For example, if we don't use the mi, then we can use by a. Now a cubed equal to a squared plus a minus I. And then we multiply the whole equation by a, so you have a to the power 4 equal to a cubed plus a squared minus a. And then you multiply again, so you get something like this. So we continue until a to the power n it is. Now by the relation, you see that 5, 4, 3, 2. So it's n minus 1, n minus 2, n minus 3. And afterwards, we will add up all these n minus 2 equations, sum them all up. So the left hand side is a cubed plus a to the power 4, a to the power 5 up to a to the power n. And then the left hand side is, now if you look at the relation, you will see that basically this will cancel, this will cancel, this will cancel. So you expect something like this. So we have the this column and this term, and also one more term here. So it is a squared plus a cubed plus a to the power 4 up to a to the power n minus 1 plus a n minus 2 minus I. And then this part and this one, they are in common, so it can be cancelled. So you have a n is a n minus 2 plus a squared minus I. Okay, and then another possible method can be do it like this. Okay, now so by a, now this is B1. Now by a cubed minus a squared minus a plus I equals 0. Okay, now so we move these two terms to the other side. So a squared minus I equal to a cubed minus a. And then we multiply the left hand side and the right hand side by a. So we have a to the power 3 minus a equal to a to the power 4 minus a squared. Now a to the power 3 minus a, we base on this result, we see that a to the power 3 minus a is a squared minus I. So this will change to a squared minus I. And afterward, we will repeat this process again. So next step, we multiply the a on both sides. And then this will become a cubed minus a again. So this one, make use of the result here. So it becomes a squared minus I. Okay. Now so we repeat it again until this one change to the left hand side always a squared minus I, the right hand side change to a n minus, they differ by 2, a n minus 2. So we arrange, we have the answer, a n is a n minus 2 plus a squared minus I.